Hey, grade 10s. Okay, so our next lesson is going to be on chemical equations or chemical reactions and the types of them. But before we do that, I wanted to do a little check-in on skeleton equations for you. So right now, I would love for you to pause this video and try this question on skeleton equations for me. Then you could unpause and check your answer. So if we were looking at this recap of a question, we are going to pick out what we're starting with. So it says dissolved hydrogen sulfide, okay, will react with potassium hydroxide. So those are my reactants. So I have hydrogen and I have sulfide. Okay, now this is not balanced because sulfur has a charge of 2 negative and hydrogen has a charge of 1 positive. So that means I need a little 2 here. Okay, it says dissolved, so my state is aqueous. All right. My next compound that it reacts with is potassium hydroxide. So potassium is K with a charge of 1 positive. Hydroxide is a polyatomic ion. So that's at the top of our periodic table, which is OH. Okay, this has a charge of 1 negative, so this is balanced. It says potassium hydroxide solution, which tells us it's in aqueous form or state. Okay, so our products, it says to form water and potassium sulfide. So water is HOH, and that is liquid. Okay, plus potassium sulfide. So we have K and we have S for sulfide, except that's not a balanced compound. Potassium is a charge of 1 positive, sulfur has a charge of 2 negative, so we need 2 potassiums. Now this one, it doesn't tell us what it is right in the question, so that means we need to check our solubility chart, and we should find that that falls under high solubility because potassium is a group 1 element. Okay, so this is high solubility, which means it is aqueous state. Okay, moving on to our new content. Types of chemical reactions. So this would be your title of your notes. I haven't been doing this, but I will post these slides for you in Google Slide version. So if you want to, you can print them out. So there are 5 types of chemical reactions types that we are going to be looking at, and we're going to break them apart. By the end of it, you should be able to, given any example, identify what kind of chemical reaction type is happening. And then in our next lesson, we are going to learn how to predict what our products are based on what are reactants and knowing that we have our 5 types of reactions. Okay, so to start with, our first type of formation reaction is formation. So this is important. It usually takes on this general format. Okay, so X is element, usually Y is an element, and it produces a compound. Okay, so basically 1 plus 1 gives you togetherness. All right, so for an example, we have sodium just on its own, element. Chlorine just on its own, it's an element. Remember, chlorine is one of those diatomics, Hofbrinkel, that we learned about last week. Okay? It produces or forms sodium chloride, which is a compound. Okay. Our next type of chemical reaction type is a decomposition. Okay, so to decompose means to Hopefully you should be able to tell me. It means to break apart. Okay, so we're going to start with just one thing, and it is going to break apart into what it is made out of. So we have one whole, just one guy completely on his own, and chemical reaction happens, and then it's broken apart into its separate, simple things it's made out of. So for example, if you have a compound of water, okay, it breaks apart into hydrogen and oxygen. So compound, breaking apart into element 1 and element 2. All right. Third type of chemical reaction, this is where they start getting a little trickier. Single replacements. All right. So a single replacement is when you have an element to start with and a compound. Okay. When you get the chemical reaction happening, you will find in the products, you actually get a different element on its own and a different compound. Okay. So how this works is the following. You have one element, and here's your compound. So this is a single replacement. So it's a single replacement because you will notice what happens is you are going to get things that switch. So in this example, our element happens to be an anion, okay, because chlorine has a negative charge. So that's our anion. So depending on what the compound, the element is, okay, depends on what it's going to switch with in the compound. So this element is an anion, so it is going to switch with the anion of the original compound. So these guys are going to just play a little switcheroo. And they are going to produce, so now, because they have switched places, sodium now has chlorine in it, and bromine is on its own. And that is a single replacement. In the following example, okay, our element on its lonesome is sodium. Sodium has a charge of +1, so this is a cation. Ooh, that does not show up very nice, does it? Go more blue again. Okay. So our cation is going to switch with the cation of the compound. And so remember, our cations are always wrote first in our compounds, our ionic compounds. So hydrogen is your cation here. So hydrogen and sodium are going to switch. Okay. And now we get sodium with chloride and hydrogen on its own. Now hydrogen, because it's on its own, still has to be H2 because it is diatomic, even though it wasn't H2 on this side, because when a hydrogen is just on its own, it gets to be diatomic. It has to be diatomic. Okay? We'll do a couple more examples once I've introduced them all to you again. Now, double replacements, guess what? Two things are going to end up switching, not just one. Okay, we always have two compounds in this example. Okay, so you have one compound, another compound, and then they're going to have a little switch, and you are going to get two different compounds. Okay, so in this case, it's easy. Most of you find this one easier than the single replacement because the cations are what is going to switch. Okay, so they exchange places. As soon as you see a precipitate reaction or usually a neutralization reaction, Remember, neutralization is when you mix an acid and base and gives you salt and water. That is a refresher from what we talked about way back when. These are always double replacements. Okay, so I'll give you an example. HCl, hydrochloric acid, okay, and we have sodium hydroxide. Acid, base. This is a double replacement. How it's a double replacement? First off, we can identify that HCl is a compound and sodium hydroxide is a compound. Okay, so saying that, I'm going to identify the cation in my first compound and cation in my second compound. And these guys are going to switch places. And when they switch, you will notice, well, now sodium is actually with chlorine. Ta-da! And because they switched, hydrogen is now with hydroxide, which is water, aka HOH. One of the other reasons we write it in this format. Okay, and our last type of chemical reaction is hydrocarbon combustion. Usually it is just called a combustion reaction. And that's how you're going to identify it for me and how you're going to see it on your quizzes that you're going to get on this to do some practice. Okay. The reason it's called hydrocarbon is you can get a combustion of other types of compounds, but we're focusing on hydrocarbons. So a hydrocarbon is honestly a compound that contains hydrogen and carbon only. It can be in different amounts depending on what it is. So it could be CH4, it could just be CH2, anything that just has hydrogen and carbon. So a combustion reaction is easily identified when you see a hydrocarbon plus oxygen. In order for combustion to happen, oxygen gas has to be present, and it always produces water and carbon dioxide. And there is no doubt about that. So as soon as you identify the hydrocarbon and oxygen, automatic, don't even think about it, carbon dioxide, water. Don't even have to go more complicated than that. So this is an example. So we have CH4, so there's your carbon, there's your hydrogen, so hydrocarbon. There's your oxygen that has to be present in order for a combustion reaction to happen, and your carbon dioxide and water. Okay. So this is sometimes the format that you'll see them in just general form. So we have A plus B gives you AB. So this is your formation. Started with your basics, separate elements combined to make a compound. The second one, this is your decomposition. You start with a single compound and it breaks apart into its elements. Please don't switch on me. Oh, what's happening? Okay, so this is a decomp. This next one is a single replacement, okay, because you have a single element on its own and a compound, and they are going to switch places. And then you have your double replacement because you have two, aka double compounds. And then our fifth one isn't represented here just because it doesn't work well in this format. So to give you some examples, now I actually pulled these right from your assignment I'm going to attach to this lesson, so you can fill them in on yours if you'd like later, but that way you have a starting point so you know what the template looks like. Yeah, so your first question on your assignment is basically what type of chemical reaction is happening. And then for practice, if you want to, highly suggested, make sure they're balanced at the end. Okay, so our first example or question is we have copper which is an element. Once I identify element, okay, well, there's only one kind of reaction that works that way, and it is a together. So you get one single compound. So this is a formation reaction. Okay, the next one, this guy, it's just one compound on its own. It breaks apart into an element and an element. Because it breaks apart, that is a decomposition. One second, sorry. Okay, number 3, you'll notice I have an element here, okay? But then I have a compound. So an element and a compound. Oxygen is not present here. It's not a hydrocarbon present here. So once I see an element and a compound, I'm going to just notice, pay attention, because this is where I'm going to take you. Okay, iron is a cation. It has a positive charge. So that means I should see a nice single switch. So iron and hydrogen are going to switch places. So I get hydrogen on its own now because it's over here. So it's H2 and iron 3 oxide, or iron oxide. I'll worry about that compound bit later. So this is a single replacement. Okay. Number 4, I can identify that this is a compound. This is also a compound. And my products, I actually also have 2 compounds. Only type of reaction that works like this is a double replacement. Post any questions you guys have down below in the comments of your lesson, please. And we have our Zoom video meet on Thursday. So if you want to ask any clarifying questions, please show up to that. Have a good rest of your day, guys. Bye.